Hello everybody, it's Mrs. Brabant. I am going to create or do this video to model target 3 and 4. So what's happening for Unit 4C in rational functions, which you see all over the screen here, what's going to happen is we are going to discuss actually three important characteristics. So I'm not going to be doing intercepts, but we are going to be doing vertical asymptotes, we are going to be doing holes. They're similar in the way you find them, but a small difference. I'll show you that. And then I am going to be doing x-intercepts. So let's not forget that a rational function, just really carefully, as a parent function, usually looks something like that. But what happens is when you start adding more to the fraction, as you see everywhere here, look at all these different numbers going on. Because that value that I just drew is just 1 over plain old x. But if I start adding other numbers to the fraction, it's going to change the shape of that graph and it's going to move it all over. It might break it up and form more curves. So that's what I'm going to talk about right now. So for vertical asymptotes and holes, the formal word for that is removable point of discontinuity. Removable discontinuity. Removing meaning it comes out of the fraction. Discontinuous means it causes a break. So we've got to figure out when is there just a VASI or when is there a hole. I want you to look at the first three under target 3. They all look super similar. So compare the top to the bottom, and the top to the bottom. If you look at the third one, there is something in common. That is the scenario, the case, where we have a hole. So I'll come back to that in the end, but I want you to notice they do look similar across the way, but when there's something in common, that's a hole that's going to be found. So I will do that later. So let's start with the vertical asymptotes. Asymptote means it's a straight up and down line that will cross the x-axis and cause a break in our curve. So what we have to do is find it. And where do you find it? You find it in where the breaks happen in the fraction. So fractions you have to be very careful in a denominator because you don't want 0 in the denominator. Because if 0 happens in the denominator, the math can't be done. And if the math can't be done, we won't be able to graph that part of the curve. So that's where it comes into line. So what you do is you find the denominator, you say to yourself, let's set it equals 0 to see where the break is. Find the denominator, let's set it equals 0 to see where the break is. If there's 2 of them, we do that. And then I'll show you why this is different later. We're not going to do that today. And then you just solve them. So we have our first vertical asymptote at x equals -2. And then over the second, we have a vertical asymptote twice, once at 3 and once at +1. So what that does, again, is it takes this situation here that used to be just x equals 0, and it moves it left or right. So I'm not going to do the whole graph, I'm just going to do the vertical asymptote. So I'm not going to do the wings or the branches, but we would go to -2 here and we would drop this vertical dotted line in so that when I start drawing my curve eventually, I know I can't touch that. Over here though, we have to be a bit more careful because we're going to not only have one at 1, but also at 3. So this one would be a few more branches in the curves because there's more breaks. So those wings here, those wings are what they're called branches. Those would be a little different in the second one because I have 2 dotted lines. Now let's get to this third one. So this third one, and I'm going to do this in a different color so you recognize we're different. This third one, the problem is it looks like we have 2 things in the bottom, but one of them is like the other. So that means we have to remove that first. Let me give myself some more space here. If I remove that, meaning cancel it, I'm going to make a new equation, which is 1 over x minus 1. That looks so much easier to handle for me. I don't have that extra step of x minus 2. So what that does is it tells me now I have 1 vertical asymptote at x minus 1. But because I removed this, and remember RD stands for removable discontinuity. Remove meaning reduce, discontinuous meaning break. So this now we have a break which we call a hole, at this position. So at x equals 2, we actually have a hole. But at x minus 1, let's do that here, we actually have the vertical line. Okay, so what's going to happen literally as we start this picture, again, I'm not going to graph the whole part of the curve. I'm just going to show you these breaks. We now, as we look at this, have two different scenarios coming up. We have a dotted line at 1. There's your vertical asymptote, also known as a VASI. But now we have this hole at 2 comma something. 2 comma something. So we're going to have to put a hole on the graph. So in order to find the something, which is a y value, we literally take our 2, put it in for substitution there, and see how it turns out. 1 over 2 minus 1 equals 1 over 1. So we have 1. So at 2 comma 1 over 2 of 1, we're literally going to have a hole there. So when I start drawing my curve, which I guess I'll go ahead and show you, we're going to jump right over it. And then over here, we're going to actually just do that opposite there. And that will show you the curve on that spot. So that's the vertical asymptote and the holes. They're very similar. Now let's go down to x-intercepts. They get a little different, but they're going to feel the same. The reason they're different is you don't look at the same place. So up here, you look at the denominator. But down here, you're going to look at the numerator. And then you're going to play the same game. So we take this and set it equal to 0. So there's an x-intercept. In this case, we look at the numerator and set it equals 0. So when I solve it, there's the x-intercept. Now over here, we can't set that equal to 0 because remember, we reduced it. So if you look at this third one, and I try to set it equal to 0, that doesn't make sense. I can't do that problem. That means there's no letter in the numerator. There's a weird solution here that doesn't make sense. So that means there's no x-intercept. So I'll show you how that looks on the graph. Let me pick my red pen up. X is equal to 0. That means when I start drawing my curve, I'm going to have this right here as a crossing point. So when I finish the rest of my curve, I'm going to be able to see, oh, you know what, it's going to sweep right through this. And that's what's going to happen, okay? On the second one, I have an x-intercept at -1. That's back here. That will help me decide where my curve is. Now, I can't sweep a curve. I need a little bit more here. I'm going to have to make a table and kind of see where the rest of this is before I finish that up, because there's obviously going to be more going on there. But that's going to be one part of the graph. And then over here, there was no intercept, which makes sense because do you see how it hugs the x-axis and it doesn't ever touch it? No x-intercepts. So those are some characteristics of irrationals. I'm going to stop this video, close it out, and then I'll do another video on some more characteristics. So again, Unit 4C, graphing rationals, these are some of the special characteristics.